If you want to learn Mergesort and the implementation of Mergesort in C, then you are in the right place. In this video, I'm going to teach you Mergesort, the basics, how the algorithm works, and the implementation in C. Well, I have made a previous video on Mergesort, but the audio there is pretty bad, and well, it is a detailed video on Mergesort. Uh, in that video, I code the entire Mergesort from scratch, and you can check it out. But in this video, I'm not going to code the entire Mergesort. I have written the Mergesort algorithm here. I mean, I have implemented the Mergesort algorithm in C, and I'm going to teach you line by line what I have written here. I'm going to explain line by line what I have written here, and you're going to get the idea. I am pretty confident about it. Well, uh, before I begin with my talk, I shall first show you that this algorithm really works, because in the previous video there was some who was saying this algorithm does not work. So yeah, let's show that let's show you guys that this algorithm really works, and I'm not faking or anything like that. So in this array we have these elements, and as you can see, these elements are not sorted. So let's try to sort them. I run this algorithm and it says the entire array is, it means the entire sorted array is 0 3 4 6 7 7 8 9. So this thing is sorted. Now let's change some things here. Let's put in some new numbers, as let's say 6 and then 7 and then 2 and then 1 and then 7 and then 9 and then 1 and then 1 and then 4 then 5. Okay, how many numbers are here? 1 2 3 4 5 6 7 8 9 10. So there are 10 numbers, so that means it has to be up to 9. Why it is up to 9, I will explain it later. So let's try to run this, and the output which we are getting is 1 1 1 2 4 5 6 7. So this algorithm really sorts the array. It is not fake, it works for every single input, and I've tested it. So if someone says it is not working, that means you're making some mistake. Anyways, in this in the description of the video, I'm going to post this source code so you can check it at but I think that there's a problem posting source codes in the description. I think there's some issues there, so I may have a link in GitHub where you can copy the code, but I'm going to do something about it. Okay, so um, let's give one more input just to clear the point that it's really working. So let's have another input like 8 7 4 5 6 9 1 2 3. So how many inputs are 1 2 3 4 5 6 7 8 9? So 9 means it has to be 8. I shall explain later, and let's see. The output is 1 2 3 4 5 6 7 8. So guys, it is working 100%. And okay, let's begin with the theory. So this example, this image, actually I have pulled from this website. It is Geeks for Geeks, and it's very common website, but uh, actually it has already got this image well formatted and everything. So I just pulled it up, and yeah, so I'm using it. I'm going to use this software here to draw on the screen. If you want, I can also give a link in the description of the software. Anyways, so uh, this is my initial array. Okay, this is my initial array, and what the merge sort algorithm tells us is, if we have an initial array, then divide the array in half. Okay, so divide the array in half. So how many elements are there? How many elements are there in this array? It is 1 2 3 4 5 6 7. So there are 7 elements in this array. Now let's change the size of this, actually. Yeah, so there are 7 elements in the array. There are 7 elements. So what is half of 7? 7 by 2 is 3.5, but you cannot have 3.5 You can have 3.5 actually, but when it's a whole number, and in mathematics 3.5 will be rounded up to 4, but in C it's rounded down actually. But anyways, so it's divided in half, means one part would be one part would be of size 4, and the other part will be of size 3. So this is what is it should happen, and in this diagram it's written here that this subarray is of uh, this subarray has 4 elements and this subarray has 3 elements. So I'm going to repeat again. What the merge sort tells us is we divide the array in two halves. So we divide the array in two halves. So if the array has 8 elements, we divide it in 4 elements per array. So 4 elements is equal to 8 elements. So we divide the array in half. So but if the array has 7 elements, we divide the array in half in the form of like 4 elements in one subarray and 3 elements in the other subarray, but we have to divide the array in half, more or less in half. Okay, now what now, like we have divided the array in half. Now the next step the algorithm tells us is we have to call the merge sort function on each of the subarray. We call the merge sort function on each of the subarray. Now this is something which you have to imagine. Now imagine there is a function merge sort, and imagine this function works like okay, I have pulled up another image from Google. It is an image of a black box actually. This is a black box. So imagine merge sort function to be a black box. You put in some input and it gives you some output. So this is merge sort. Merge sort function, you put in some input, you get some output. Now you don't know how this happens, but you know it works every time. So you give in some input, you get an output. So you give in an unsorted array, it gives out a sorted array. So imagine this function works, it exists. Okay, so now let's go back to discussion. So what this merge sort algorithm says, like we divide the array in two sub arrays, and then we call the merge sort function on each of the sub array. We call merge sort function on each of the sub array. So what will happen if we call merge sort function each of the sub array? As I said, we assume that it works. So if it works, then the merge sort function should sort this array, and you would get something like this. So merge sort function is sorting the array, and you would get something like this. So what we are getting now is let's change the color. What we are getting now is we are getting two arrays who are sorted in them, but we want to get the big array sorted. Big array can be sorted by finding the correct position of these elements in the big array. For example, 3 is the smallest element, right? So 3 should come here, then 9 should come here, then it's 27, so 27 should, I'm sorry, then is 10, so 10 should come here, then it's 27 should come here, then it's 38 should come here, then it's 43, then it's 82. So I'm going to repeat again. This array is sorted, this array is sorted. So what the merge sort function does is it divides the entire array in two halves, then it calls merge sort function on each of the arrays. So we assume that merge sort function sorts the merge sort function, it sorts these array, it sorts this array, and we get this array, So what we are getting now is we are getting two arrays who are sorted in them. Like these two arrays are sorted, like 3 is less than 27, 27 is less than 38, 38 is less than 43. So these two arrays are sorted in them. Now we can get the big array by merging the sorted arrays. If we merge these two sorted arrays, we can get the final array, final unsorted array in a sorted fashion. How this is done is, if we can correctly position these elements in the final array, like 3 is the smallest element, so 3 should come here, then 9, then 10. So in this fashion we can get a sorted array. What this means in other words is, we are merging two sorted arrays to form a final sorted array. So this is entire thing of merge sort. Now let me explain this thing one more time. I don't want to repeat myself, but just to make the concept more clear. So we have one big array, we call the merge sort function on this array. It divides this big array into two small arrays, and after dividing this big array in two small arrays, it's calling the merge sort function again on each of the subarray. So it's calling the merge sort function on each of the subarray. So merge sort function on this subarray would further divide this array into two other small arrays. Merge sort function on this subarray would divide this array into two other small arrays. Then again merge sort function is called on this subarray and this subarray. So merge sort function on this subarray would again break this subarray into two further subarrays. Now if there is only one element, then you need not break it again, because one element means the array is already sorted. Suppose you have only one element in the array, so what does it mean? It means that the array is already sorted. So at this stage the array is already sorted. Now we have to combine them, we have to merge them. These two arrays are sorted arrays, so we have to merge them. So the merge array function is called now. So it merges these two arrays to form a big array. Like this one was the unsorted array and this is a sorted version. 27 comes, just change the color, 27 comes here, 38 comes here. So this is the unsorted array and this is a sorted array. And I am saying arrays, but I mean sub arrays. This is the unsorted sub array, this is the corresponding sorted sub array. So in this way every single array is broken into sub arrays and then again joined to form a sorted sub array, and this sorted sub array is merged with this sorted sub array to form this sorted sub array, and similarly this one is merged with this one to form this one. So this, in this way, the entire array is sorted. So this is the theory behind merge sort, and now I'm going to explain you the code, the C implementation of merge sort. So this is the source code. It's a pretty basic C program. I've not used any pointer, it's simple, it's arrays. And let's begin. So I start with simple, okay, let's increase the font a bit. I start with including stdio and conio. These are pretty basic stuffs, you can include them, and I do them actually. Okay, then I need two helper functions. The two functions which I need is merge and merge sort. So merge sort is the function which will actually implement the merge sort algorithm. Okay, so let's see the merge sort function. So this is the merge sort function. It accepts an array as input and it accepts two other parameters, and these two parameters are low and high. Means if this is the array, then at the first call we have to give the address of this element. Okay, let's change the color. Then at the first call we have to give the address of this element and the address of this element. Now in you should be knowing that in C, array index starts from 0. Array index starts from 0 and it is up to n minus 1. So 0, 1, 2, 3, 4, 5, 6. So it is 6. But what is the length of the array? The length of the array, let's increase the color, I mean the size. The length of the array is 1, 2, 3, 4, 5, 6, 7. The length of the array is 7, but array index starts from 0 and goes up to n minus 1. So uh, this is the reason I have given two variables, low and high. Low would mean um, low would mean this one, array of the, I mean index of this element, and the high would mean index of this element. So this is low and high. Okay, now int mid. So if low is less than high, okay, tell me, when is low going to be equal to high? When is low equal to high? What have I said? What I have said? I have said is the index of the first element is low, the index of the last element is high. Okay, so when can these two index be same? These two index can be same only if there is only one element in the array. In these cases, low is equal to high. In these cases, low is equal to high. So what will happen if low is less than high? If low is less than high, I mean, what am I saying? Okay, in this cases, low is equal to high. So if low is less than high, it means there is more than one element. So that means the array has to be sorted. But if low is equal to high, that means there is only one element, and as I've said, one element array means it's already sorted. So let's remove this. One element array means it's already sorted, so we need not bother about it. So if low is less than high means there are more than one elements. So what I do is mid, to calculate the mid. So mid is low plus high divided by 2. How? Low is 0, high is 6. 0, 1, 2, 3, 4, 5, 6. Low is 0, high is 6, and 6 plus 0 by 2 is 3. So 0, 1, 2, 3. This is the first subarray, and 4, 5, 6. This is the second subarray. So in this way the array is divided. So mid is low plus high by 2. Then we call the merge sort on the first subarray and merge sort on the second subarray. How? Well, merge sort has these three parameters. The first one is array, second are the indexes. So I am passing low and mid. What is my mid in this case? My mid in this case is 3. So I am passing low and mid. So this is my new subarray, which is this one. And in your second case, I am passing mid plus 1 up to high. So mid plus 1 is 4. So up to this one. So this is my second subarray. So and in this way I am in this way I am breaking the array into two subarrays, and I'm calling the merge sort function on each of the subarray. And after these two lines are executed, I am sure that these two subarrays are sorted. Now we have to merge these two sorted subarrays. So I call the merge function. Sometime back I explained how this merge sort recursively sorts the array. Now I'm going to explain the merge function, what it does. The merge function accepts an array as a parameter, and then p, q, r, r. P means low, q means mid, and r means high. Okay, what is n1? N1 is length of the left subarray, and n2 means n2 means length of the right subarray. What do I mean? What I mean is, this is my left subarray, this is my right subarray. Just for clarity's sake, we the programmers write like this. So length of the left subarray, length of the right subarray. Then we then I create two arrays L and R. Or what is the length of L? Length of L is n1. What is the length of R? Length of R is n2. Now for I equal to 0, I less than equal to n1, I plus plus means up to the full length of L1. I mean up to the full length of n1. Up to the full length of n1, I do this. What I do is L of I is equal to AR of P plus 1. What I mean is I created the array L and I am putting in all the values of this subarray in L. That's what I'm doing. Same thing I have to do with this right subarray also. So for I equal to 0, I less than n2, I plus plus, R of I is equal to AR of Q plus 1 plus I. What is Q? Q is mid and Q is mid, and the right subarray is this one and mid was this one. Right, mid was this one. So mid plus 1 means 9. So this is mid plus 1. Then mid plus 1 plus 1, mid plus 1 plus 2. So this is what is Q plus 1 plus I, and we have to put all this element in the right subarray. So what I'm doing here is R of I is equal to AR of Q plus 1 plus I. Then L of n1 is a very big number and R of n2 is a very big number. This we are giving just for like just to just tell the program that okay, the left subarray is finished, the right subarray is finished. It's not very important, but just do this. It works this way. Then I equal to j equal to 0, and then for k equal to p, k is less than r means k equal to low, k is less than high, k plus plus. If L of I is less than R of j, what it means is if left of I means this element is less than R of j, this element, if this element is less than this element, then what to do? If this element is less than that element, then AR of k is equal to L of I plus plus. It means is, what it essentially means is, just a sec, um, AR, just a sec, AR of k is equal to L of I plus plus. What it means is if this element is less than this element, then in the array put this element first and then compare this element with this element. So now this element is less, so put this element here and increment the value of j to j plus 1, and then let's compare this element with this element. This is small, so let's put in this, increment the value of j to here. Now this element is less than this element, so this element is coming here, then incrementing to here, this is less than 82, so it's coming here. Then 43 is less than 82, so 43 comes here, the 82 comes here. This is what is happening. And so if L of I is less than R of j, then do this, else AR of k is equal to R of j plus plus, means if the element in the left subarray is less than element in the right subarray, then in the final array put in the element of the left subarray, else put in the element of the right subarray. So in this way we are merging the two sorted arrays, and yep, this is how the program works. And in the main method I am just declaring a variable, an array actually, and initializing it like this. You can do a user input, but I'm not doing it because it would just take some more time for me and I don't want to lose time. I mean, it works like a static array, so why put in some user inputs? Anyways, you can do that, it will work, no problem. And we're calling the mergesort function on this array. And what are the arguments? The arguments are low and high. What's the value of low? The value of first element, the index of, I mean the index of the first element, and index of the first element is 0, so I'm putting in 0. and what is high? Index of the last element. So I'm going to put in the index of the last element here, and that is 8. So I'm calling the mergesort function on this. I'm calling the mergesort function with these parameters, and it would sort my entire array. And now I'm going to print the entire array. I guess you don't have any problem in understanding the print statement. It's pretty straightforward print statement. I'm just looping through, like, for I equal to 0 to 8 I plus plus, and then just printing the elements. So it's pretty easy. And let's run it once. 1 2 3 4 5 6 7 8 9 means 0 to 8. Okay, 1 2 3 4 5 6 7. So this is working, and um less than equal to 8 because I missed 9 here. So alright guys, as you can see, this function is working. What you could have done is, instead of putting 8 and 9 like that, you could have just put n is equal to 9, and here you could have put n minus 1, and here you could have put less than n. And if you run it, you should be getting the same result, and this is a better way of coding. So this is it for this video, guys. I hope I could explain Mergesort, and if you like this video, do hit the thumbs up, and I'll see you guys next time. Thank you.